Now, good morning, student. Today's session, the surface areas and volumes. So far, we are studied about the surface areas and volumes of all the three. Just I'm giving a brief one. Here is first one is curved surface area, and second one is total surface area, and third one is volume. Okay, now here the objects, the solid object, just look at this. So one is a cube and cuboid, and then cylinder, cone and sphere. Cube, CSA or LSA. Okay, so 4a square. Total surface is 6a square, and this a cube. Volume of the cube is a cube. Cuboid, what is that? Lateral surface area is 2h into L plus B. 2h into L plus B. Then total surface area 2 into LB plus BH plus LH, and this length into breadth into height. Okay, now the next one is a cylinder, right circular cylinder. Right circular cylinder. Its curved surface area is 2 pi r h, and this is 2 pi r into r plus h, and volume is pi r square h. Then next is a right circular cone. Right circular cone. First one is a curved surface area is pi r l. Pi r l. Then second one is pi r into L plus h. Okay, so pi r square, you are taking that pi r square, pi r l plus pi r square. Then pi r common, r plus l you can write. Then this is 1 by 3 pi r square h. 1 by 3 pi r square h. Then sphere. Sphere, there is no lateral surface area. Total surface area is 4 pi r square, and this is 4 by 3 pi r cube. Look at that. The volume of a sphere is 4 by 3 pi r cube. Then one more is a hemisphere. Hemisphere. So hemisphere curved surface area CSA is 2 pi r square. 2 pi r square. TSA is 3 pi r square, and volume is 2 by 3 pi r cube. So these are the three major formulas. So here sub formula is there to find out L. To find out L, you should use L is equal to square root of r square plus h square. This is to find out the length, slant height of a cone. So these are the main formulas in the surface areas and volumes. Clear? So you should write down this in a sheet and paste it in your class note. So whenever you want to do the problems, then you can go through this. Okay, practice this. Now I am doing problems mixed of all these things. Okay, mixing problems. How to do this one? Now, how many cubic meters of earth must be dug? How many cubic meters of earth must be dug out to sink a well 14 meter deep and having a radius of 4 meter. Having a radius of 4 meter. Question mark. If the earth taken out is spread over, if the earth taken out is spread over a plot of dimensions dimensions 25 meter into 16 meter. 25 meter into 16 meter. What is the height of the platform? What is the height of the platform? Height of the platform so formed. This is the question. So it takes time to write. Just go through this. How many cubic meters of earth must be dug out to sink a well 14 meter deep and having a radius of 4 meter? Okay. If the earth taken out is spread over a plot of dimensions 25 meter into 16 meter, what is the height of the platform so formed? So read the questions carefully. Okay. Now here earth is dug out in the form of a well like this. Okay. Its radius is given. Radius is 4 meter. 4 meter area means radius. Then height is 14 meter. Height is 14 meter. Then we are removing a mud from that. Okay. Dug out that sand what you are taken out earth, that it should be spread into a platform like this. So whatever the earth we are taken out from this, it is spread into form a platform. Its dimension is given. How much that? 25 meter into 16 meter. Then this is 25 meter and 16 meter. Then we should find out h. Height is question mark. So here the question is simple. we have to find out the volume of this sand, earth taken out, that you should equate to the volume of the cuboid. Volume of the cuboid, then you will get the answer. Clear? So, volume of the cylinder and volume of the cuboid. Clear this? Now, first thing is, first volume of the earth. Then here, solution. First you write down R is equal to 4 meter, H is equal to 14 meter. Then first one is pi R square H equals, pi R square H is how much? 22 by 7 into 4 into 4 into 14. Then 7 ones are 7 twos are. Now 22 twos are 44 into 16. 16 fours are 64. 16 fours are 64. 6 70. 704 square meter, cubic meter. So, what is the earth which is removed from this well? That is equal to 704 cubic meter. Now, this cubic meter, then you should take the dimension, second part. Dimension of the area of the given plot. Area of given plot, that is equal to, what is that? 25 into 16. 25 into 16. That is equal to 400 square meter. 400 square meter. Okay, this is the area of the platform. Area of the platform. Then we have to find out the height. So, third part, height H is equal to volume by area. So, this is another formula to find the height of the platform. What you should use? Volume by area. So, what is the volume? Volume is 704 by area is 400. Volume is 700 by 400. That is equal to 176 by 100. That is 1.76 meter. 1.76 meter. Are you clear this? See, this is what the area of the given platform is. Plot is 25 into 16, that is 400 square meter. Are you understood? Now, this is the volume, and volume of the cuboid is length into breadth into height. That is equal to this one, pi R square H. So, length into breadth is given 400 into H is equal to 704. You can use like this also. You will get the same answer. Understood? So, this is what the volume of the earth. The same problem is there in your textbook also. You should go through that. Clear? Now, look at the second one. Find the number of coins. Find the number of coins 1.5 centimeter in diameter and 0.2 centimeter thick to be melted to form a right circular cylinder of height 5 centimeter and diameter 4.5 centimeter. Remember here, if one solid object is converted into another one solid object is converted into another one, then we should always use the volume. We should always use the volume of the two objects. Clear? So first we should find out this. So solution, what is the solution? You know that the coins, here is the coin, one say 5 rupees coin, you know the thickness and the circular radius. Okay, so like that how many coins we should melt to form a cylinder of height 5 centimeter and diameter 4.5. See, here is the cylinder whose height is 5 centimeter and its diameter is 4.5 centimeter. So in both the cases they are given the diameter. So they given diameter. First convert that. D1 of this is 1.5 centimeter. Okay, then R equals 1.5 by 2, and in this D equals how much, that 4.5, and capital R equals 4.5 by 2. Clear? Then here this is the cylinder. Height is given. Height, thick means height. H equals 0.2, and here H equals what they given, 5 centimeter. Okay, in order to convert this, just you take down, remove the decimal point, 15 by 20, and this is 45 by 20. Okay, now this is the bigger one and this is the smaller one. Now how many coins we want? That means divide the volume of this cylinder by the volume of one coin, then you will get the required answer. Okay, so number of coins is equal to volume of cylinder by volume of one coin. So volume of cylinder is what is that? Pi r square h divided by, here is pi r square h. Are you understood this? Here you can cancel this pi. Then substitute the value. R square is 45 by 20 into 45 by 20. I am written twice because r square, and h is given by 5 whole divided by, in this r is 15 by 20 into 15 by 20 into, here h you can write this as 2 by 10. H is 2 by 10. See, conversion of decimals into fractions, it is easy to do the calculations. So here all these things, the denominator fractions, you should do it reciprocal. So what you will get? 45 by 20 into 45 by 20 into 5 by 1 into 20 by 50 into 20 by 15 into 10 by 2. Everything changed into its reciprocal. Now cancellation, 20 cancel, 20 cancel. Now 15 ones are 15, 15 threes are 45. 15 ones are 15, 15 threes are 45. Okay. Now here 2 ones are 2, 5s are. Now left out is 3 into 3 into 5 into 5. That means 5 5s are 25. 5 5s are 25 into 9. 25 into 9 is 25 4s are 100. 25 8s are 200. 225. 225 coins are required to make this cylinder. We should melt 225 coins of this dimension. 225 coins of this dimension if you melt, and you can recast into a cylinder of this dimension. Okay, here the important thing is convert the decimal numbers into fractions, right? And then keep the fractions as it is because it cancel easily. So do this, work out this twice or thrice, drill work the same problem, and then go for your exercise problems. See, I am doing a different problems apart from your exercise one because you are at home. So do the problems what are there in the exercises at home, because you have the reference books. Go through that. Even if you have doubt, you can call me at any time. Clear? So this is another one different questions. Now the next, the tent is in the form of a right circular cylinder surmounted by a cone. The diameter of the cylinder is 24 meter. The height of the cylindrical portion is 11 meter, while the vertex of the cone is 16 meter above the ground. Find the area of the canvas required for the tent. Okay, here the same problem you are seeing in the 10th standard also. So learn here itself. First is solution. So what is given? You write down the cylindrical part. Cylinder area, curved surface area of cylinder plus curved surface area of cone. So here this is 2 pi r h plus CSA of cone is pi r l. Now look at that, they are given the diameter. So how much the right circular cylinder surmounted by a cone. The diameter of the cylinder is 24. D is equal to 24 meter. Then R is equal to 24 by 2, that is 12 meter. The height of the cylindrical portion is 11 meter. H is equal to 11 meter. While the vertex of the cone is 60 meter above the ground. So the cone height is equal to 16 minus 11, that is 5 meter. And the radius above the ground, the radius of this cone radius is also same as this cylindrical one. So first find out the slant height. L is equal to square root of h square plus r square. Square root of h is 5 square plus 12 square, that is equal to square root of 25 plus 144. So square root of 169. L is equal to 13 meter. L is equal to 13 meter. Okay. Now here this R given now. All the things we know that. Now substitute the value. Here pi r both are common, so remove that. Pi r as common, left out is 2h plus L. Now 22 by 7 into r value. So r is in both the case is 12 into 2 into h. That means this is the cylinder height. Cylinder height is 11 plus slant height of the cone is 13. That is 12 2s are 24. 24 plus 2, 26 by 7 into 11 2s are 22 plus 13. is 35. 7 ones are 7 5s are. So here is multiply this. 5 4s are 20. Carry 2. 5 6 are 30 plus 2. 32. Carry 3. 5 2s are 10 plus 3. 13 square meters. 1320 square meters of cloth required, canvas is required to build this tent. Clear? You can separately do the work and then you can add it. So better in the 10th standard also you should do the same like this. Okay. So what are the asked one? See, here is cylinder CSA plus CSA of cone. You should add both, then you will get the total surface area of the tent. Clear? So first thing is what is given, you write down that. When they are given the diameter, always convert that into radius by dividing it by 2. Then in case of cone, find out the slant height. So look at once again cylindrical area, cylindrical curved surface area plus curved surface area of cone. Formula you should write down like this. Then here what is given? So diameter, then radius, height of the cylinder, this. Then cone height, cone radius, same 12 meter. Then we want the slant height. So slant height is given by L is equal to h square plus r square. So when you substitute the value of r value and h value, you will get a 169. Square root of 169 is 13. Okay. So this is one more type, the combined one, cylinder and cone together. You are finding the values of this. Clear?